Back to another video on induction. So we have A equals the matrix 3 0 1 1, and we're going to prove by induction that for all positive integers n, so once again this is very important, for all positive integers n we have 2 times a to the power n is equal to 2 times 3 to the power n, 0, 3 to the power n minus 1, and then 2. Okay, so once again, base case, and in this case our base case is going to be n equals 1 because positive integers, the smallest positive integer is 1. So we have n is equal. It doesn't really matter what you use. You can use n equals 5 as well, but n equals 1 is easy to work with. So when n is equal to 1, what do we have? We have 2a to the power 1, okay, which is basically 2 times a. So what's that equal to? Well, we just do 2 times our a is 3011, so we have 3011, and we end up getting 6022. So it's true for n equals 1. So this is very simple matrix algebra. You just multiply everything by the scalar 2. So that's done. And over here, when n is equal to 1, we have 2 times 3 to the power 1, 0, 3 to the power 1 minus 1, and 2. Which is also equal to, well, 2 times 3 is 6, 0 is 0, 3 minus 1 is 2, and 2. So true for base case. So we can write that. True for base case. Okay, and honestly matrices are the easiest to work with in terms of induction because you're going to see why. It's a very simple rule of thumb you have to follow. So again, assume true for n equals k. This is true for every type of induction. Assume true for n equals k. So what that means is that 2 times a to the power k is equal to, and now we put k in there for everything. So we have 2 times I'm going to remove the times. I'm going to have 2 3 to the power k, 0, 3 to the power k minus 1, and is it 1 or is it 2? It's 2. And we have 2. Okay, we have that. Now, show true for n equals k plus 1. Once again, this is what we always do. And now with induction, well, for matrices, this is very simple. Like, there's always only one thing that you need to do. So when n is equal to k plus 1, we have 2a to the power k plus 1, which is equal to 2a to the power k times a. And we already have everything. We have 2a to the power k is this right here. So we have 2, 3 to the power k, 0, 3 to the power k minus 1, 2. And we're going to multiply that by the matrix A, which is also already given to us. We have 3 0 1 1. So we're going to multiply this whole thing by 3 0 1 and 1. And what do we get? Well, if you know how to do matrix algebra, you should see that we'll end up getting, and our first entry is going to be this times this plus this times this. So we are going to have 2 3 to the power k times 3 is 2 3 3 to the power k. I'm going to write it like this for now, plus 0, because 0 times 1 is 0. Then we're going to do this multiplied by this, so that's 0, plus this multiplied by this, which is also 0. Okay, that's done. We're going to have this multiplied by this, so we're going to have 3 of 3 to the power k minus 1, plus 2 times 1, so plus 2. And then we're going to have this times this is 0, plus 2 times 1 is 2. Okay, so what do we have now? So we have this is equal to, well, instead of multiplying 2 by 3, I'm going to multiply the 3 by 3 to the power k. So I'm going to have 2, then I'm going to have 3 to the power k plus 1 over here. And then that's 0, and then this is 0 here. And now here what do I have? Well, I have 3 times 3 to the power k, so that's 3 to the power k plus 1, minus 3 plus 2, so that's minus 1. And then here I have 0 plus 2 is 2. Well, I'm going to write it in a special way, as we always do with induction, right? So I'm going to write it as 2, then I'm going to write it as 3 to the power brackets k plus 1. I'm going to add extra brackets, then I have 0. And then again here I'm going to have 3, I'm going to have the brackets k plus 1, I'm going to have minus 1, and then I'm going to have 2. So I haven't changed anything. But once again, look at this. Look at what we started with. You see that n over there? You see that k plus 1 over there. This is the k. You see that k plus 1, and you see the n. You see the n over here. You see the k plus 1 over here. And that's it. We've just matched the n to k plus 1. And the 0 and 2 stay the same. We have that 0, and we have the 2. We have the 0, we have the 2. So that means this is true for n equals k plus 1. That's it. Then, by induction, this is going to be true for all positive integers n. Positive integers n. And once again, you can see some applications of it, like how we saw in the derivative example. Well, what if I want to find 2 times a to the power 6, for example, right? Well, a to the power 6, just doing it by hand, 3011 times 3011, and then getting that and then multiplying again and again and again and again, and then multiplying by 2. Well, now I can just put the 6 in terms of n over here. So that's just going to be, well, 2, 3 to the power 6, 0, 3 to the power 6 minus 1, 2. That's literally it. This is 2 times a to the power 6. I don't have to do any calculations. Literally put 6 in for that right there and see this works. I can only do this because I've shown that this formula is actually true for this a right here. So yeah, that's another example of induction, and today we learned about induction with matrices. If you like the video, please like, share, comment, subscribe, and let me know what else you want to see in future videos.